Chapter 3 Optics, page 107. A self-operating vehicle powered by solar energy is moving on the moon. What is refraction? What are convergent lens? What are divergent lens? What are main parts of an eye? What is short-sightedness? How to cure it? What is a magnifying glass used for? How is the analysis of white light into color light done? What is the color of mixing color lights? Why do objects have different colors? What are effects and applications of lights? Unit 40, page 108. The phenomenon of refraction. Put the eyes looking along a straight chopstick from the upper edge. And we don't see the lower ending of the chopstick. Keeping the eyes on looking and pouring water into the bowl. Can we see the lower end of the chopstick? Observe figure 40.2 and give your comment about the transmission line of a ray of light from S to I, from I to K, from S to the separating surface, then to K. Conclusion. A ray of light traveled from air to water, that is, from one transparent environment to another transparent one, is bent into sections at the separating surface between two environments. That problem is called refraction. As shown in figure 40.2, people call I is the incident point, SI is the incident ray. The line NN prime perpendicular to the separating surface is the normal at the coming point. SIN is the angle of incident, symbol I, small I. KIN is the angle of refraction. The plane containing the incident ray SI and the normal NN prime is the plane of incident. Experiment. Observe a ray of light travels from air into water. Arrange an experiment as shown in figure 40.2. Immerse vertically a part of a flat wooden piece into water. Shine the ray of light low on the surface of the wooden piece to the separating surface PQ at the incident on I. Tell whether the refracted rays lie in the plane of incidence or not. Among the angle of incidence and the angle of refraction, which angle is greater? Conclusion. When the light travels from air to water, the refracted rays lie in the plane of incidence. The angle of refraction is smaller than the angle of incidence. The refraction of light when it travels from water to air. Is the above conclusion true in the case that the light is traveled from water to air? Propose an experimental plan to check your guess. Experiment of testing. The following covering method can be used to draw the transmission line of light from water to air. Arrange an experiment as shown in figure 40.3, where two pins are on the pot of a wooden piece immersed in water at the position A and B. Find a place to put the eyes so that we can see the pin B obscuring the pin A. Take the pin C to a position so that it can obscure both the pins A and B. The pin C doesn't appear as shown in figure 40.3. Prove that the line connecting positions of the three pins A, B, C is the transmission line of light from the pin A to the eyes. Comment on the transmission line of light. Indicate the coming point, the incident rays, the refracted rays, and draw the normal at the incident point. Compare the magnitude between the angle of refraction and the angle of incidence. Conclusion. When light travels from water to air, the refracted ray lies in the incident plane. The angle of refraction is greater than the angle of incidence. Applications. Distinguish the phenomena of refraction and reflection. Explain the phenomenon stated at the beginning of this unit. The phenomenon that light travels from a transparent environment to another transparent one is refracted at the separating surface between two environments is called refraction. When a ray of light travels from air to water, the angle of refraction is smaller than the angle of incidence. When a light travels from water to air, the angle of refraction is greater than the angle of incidence. You may not know. If a person doesn't know the refraction, he usually estimates wrongly the depth of water. You should note that when we practice to swim, because through our eyes, the depth of river, lake, spring, or water container, etc., looks as hollow as 1/3 its real depth. If we estimate the depth incorrectly, we may be in danger.